Alright guys, so in this video we're going to continue our talk about vectors, and the only goal, the change in the goal for this video comparison to the last one was that now we are going to look at the vectors and scalars and the relation with position and movement, but just now put it into a coordinate plane perspective, okay? And so what we're going to think about here is we've already talked that a vector has magnitude, a scalar has magnitude, but the difference is that a vector, all right, the vector has a direction, all right, so the vector has direction here. And what does this look like in a coordinate plane? Well, the question that I've seen, multiple times, in doing this is, well, how are you supposed to represent a direction when there is infinitely many types of direction, right? There's so much more than just north, south, east, west, and then the northeast, the southeast, and so on and so forth. There's so much more to it than that. There's every other angle that creates it. And so, well, how do we think about, I guess, the concept of having both magnitude and direction using two numbers? Like, how is it possible, like we normally would with a point on our coordinate grid? All right, well, interestingly enough, we can kind of think about it very similarly to how we've just done it in the past. So we know that we can represent any point in the plane with two coordinates, our xy coordinate, right? The representation is what two-dimensional vectors were exactly designed to do, okay? Directly designed to do. So let's take a look here. Let's say, for instance, we are just dealing with an extremely basic example here. Now, I'm just going to call them point A, B, because it doesn't overly matter too much. But let's say, for instance, we just have our coordinate grid. And let's say I just say, hey, here's the point A, comma, B. The position A, comma, B, right? It just represents the ordered pair, A, B. All right, well, AB determines the actual point in this coordinate plane. But it also determines the directed line segment. Now, that should be not a new term, all right? That is a term from geometry. And the directed line segment is just simply taking into account that if here's my point A, comma, B, then what's the direction formed? Well, the direction formed is from here to here. And now this directed line segment, or the arrow, represents our vector, and now we write it in what we call component form with our arrowed brackets. Okay? So kind of notice what happens there. This is the difference between position, all right, and our direction. And so we would go ahead and call this our position vector, all right? And then down there at the bottom is our vector, or this is technically our two-dimensional vector in component form. And component form is our AB. Tells us where to go and how many units are we going. Where to go and how many units. So the direction says to the right A units and up B units. All right. So as we said, the standard representation, all right, let me change some colors here. Our standard representation is from the origin, so we would consider this standard form or standard representation going from the origin and meeting up in that direction. Now, let's think a little bit more so. We talked about magnitude, talked about size, all right? Now, the magnitude of a vector. Well, how can we find the magnitude of the director, the size of the vector? Well, remember, guys, this is the magnitude that we're talking about. So the magnitude that we're going to be dealing with, size can't be negative, right? Size is it's like time. It can't be negative. All right, and so we're going to represent our magnitude of our vector v. And usually you see the vectors kind of highlighted v like this. So the magnitude of v will be the absolute value of that vector. All right, everyone still with me? All right, let's kind of keep pushing forward a little bit. So the magnitude itself, think about what the magnitude represents. If magnitude is size, well, the size of what? Well, technically it's the size or the length of the arrow and represents the direction of v, all right, or what direction the arrow is actually pointing towards us. And there's a specific type of vector that we see. It's called the zero vector. Our zero vector usually is represented as either v0 or vector of 0, where that 0 is kind of highlighted a little bit more so. You're going to see that vectors are usually kind of highlighted a little bit. All right, so our zero vector there, well, if it's going to have a 0 magnitude, well, then it didn't go anywhere, and it didn't go anywhere up either, right? So it didn't go anywhere to the right or the left, and it didn't go anywhere up or down either. So this has no length and no direction. All right. And that is going to wrap up this video, another video in which we were focusing on just simply defining some new terms. In our next video, we will start diving more into magnitude in terms of the component form, talk about directional angles, and also something called head minus tail rule as well.